To give a background, so when we consider auction, so that is used to typically sell products which does not have a standard value, or the product value actually fluctuates based on the demand and supply at a specific point of time. So we have auctioneers in two models, right? So one is called the monopolist, so who is an individual who wants to sell their product, or a monopsonist. Here it's more like a public agency or a government who wants to do a tendering or a production of a public good. So in these cases, see, the auctioneer actually establishes the product or a procurement under the auction, and the interested parties place a bid for their interested item. So from the determination of the winner, so typically if you take product sales scenarios, the highest bid value is considered as a winner, and a procurement scenario or a contract scenario, it's typically the lowest value is considered as a winner. So for a sealed bid, so sealed bid auction is one of the auction model in which again it is typically used for tendering or some unique product sale scenarios. Here only one bid is allowed per bidder, and the auctioneer selects the bid winner from the interested parties. Within the sealed bid, there is one more submodel called as the first price sealed bid auction, with which the highest price for the product sale scenario or the lowest price for the contract scenario is determined as a winner. Based on the traditional sale bid auction that we determined in our previous slide, the challenges that is there in the current model are: in case a bidder wins the auction, is he capable to make the payment? And did we consider the public opinion for the contractor who is going to lay roads or flyovers or whatever be the public project, right? Do we have a public opinion based on his previous work? Who has won the auction, and what is a bid winning value? What is the transparency around it? Is there an option to manipulate the bids in the current process? And in case of a product sale type of auction, uh, who will take the first action, right? So will bidder make the first payment, or is the auctioneer is going to ship the product first? So these are the current challenges that we see in the traditional model. From the objective of our research study, we want to leverage blockchain uh, for the sealed bid auction to cover both the product sale and the procurement scenarios. Why blockchain? Because blockchain is based on a distributed ledger technology, and the transaction immutability is its key characteristic that we want to leverage here. We want to design the methods using smart contracts for this sealed bid auction, and to determine if we are getting the correct bid winner from both the scenarios, and is the escrow account model, the finance intermediary account, is able to manage the payments correctly. So these are the objectives that we wanted to achieve as part of the study. By going through the existing literature for the 5 pillars that we want to achieve. So starting from the sealed bid auction in the FPSP model, is it covering the product sales scenario? Does it involve a finance intermediary or an escrow concept? Does it cover the procurement or a contract scenario? And at last, is there a public opinion considered for any kind of contract scenarios? So putting together all these 5 pillars, we went through the existing literature where a blockchain is used for a sealed bid auction, and to identify whether these scenarios are covered. So this is the final output. I've just summarized them, and for each of the citation mentioned here, I've given references towards the end of the slide. And we could also notice like the current studies that is there, it does not cover all the 5 pillars that we wanted to achieve as part of the study. Going through the research methodology, so we have designed the smart contracts, and the smart contracts are having 5 major structs. So one talks about the bidder information, so where it stores the bidder name, when the bidder was established, the year of establishment, the bidder data, basically bidder hash, like you can provide a company description like that. You have a bidder address, the bidder votes, which is given by the public actually, and the account number from the FI information. So from an FI standpoint, the finance intermediary, what is the bidder name, what is the account number, what is the ETH address, it's key for us to compare. So ETH address and the amount. Bid standpoint is actually a combination of the auction model. So here the auction name, who is actually the monopolist or the monopsonist name, what is the item that is part of the auction, whether that item is a product or a contract, is the auction. So based on the several auctions that can be executed in the system, what is the current auction that is enabled? What is the auction status? The bid winner name and the amount. So once the auction is complete, we can also update the bid winner name and the amount across each of this auction. And the bid value is captured in the bid struct, where it says what's a bid ID. It's a generated value, and it's a combination value of the bidder name and the auction name. So who is the bidder who is placed and the amount. So here the last one is a public vote info, which captures the voting information across each bidder, saying okay whether they can upvote or a downvote a specific bidder. So for each of the structs, we have also established methods associated with it. They can add an FI account, so get the bidder FI amount balance, return the bidder FI amount. For auction perspective, we have an add auction, start auction, whether the auction model is a product or a contract, end auction, reset auction, and the update the auction winner amount. From bid perspective, we have place bid, who is a contract bid winner, what's the highest bid value, and also the auction bid winner. So these are the different methods available: bidder registration and public upvote. So let's go through the process flow to understand it better. So here in the process flow, I have listed the roles responsible for each of this process. So creating an auction or adding an auction can be performed only by the auctioneer and the admin. And start auction is again a method. Once the auction details are added, so they can actually start the auction. And the same admin can also end the auction when they feel okay, they have got the expected amount out of the sale, so they can also end the auction. It's not a time triggered process, it is more like an auctioneer determined when they want to start and end the process. And for an FI admin, so here the bidders actually, so after the auction is made available, right, the bidders can deposit a certain amount into the FI account, create the FI reference. So FI will be creating a reference and they will give that information back to the bidder. And in the meantime, the FI admin will work with the auctioneer to add these FI accounts into the blockchain system. So once the FI accounts are added, bidders are allowed to register themselves, and once the bidders are available, the public can also upvote or downvote a specific bidder. So once a bidder is there, so based on the auction, they can place the bid. So in case of a product-based auction, where this first step is to validate whether the amount that is bid is already available in the FI account or not. So that is the first step it happens. If the amount is available, let's say he wants to bid a product for say $900, and if the FI account balance is $1,000, great. So the amount is first adjusted in the FI balance and then the bid is placed successfully. If the amount does not match or it is less than what he's trying to bid, let's say the current FI amount is only $800, but he wants to place a bid for $900, that is not applicable, and this is actually errored out. In case of a contract based auction model, we do not have to validate this amount. We would actually take the bid value and then place them in the blockchain. So as we spoke earlier, the auctioneer determines when he is decided to end the auction. There is not a timer specific, but it is more of a option we are giving to the auction when the amount that he wants to sell the product, if he is actually seen it as a bid value, he can actually go ahead and end the auction here. Last, so who is the winner of the auction? So in case of a contract scenario, the winner is determined based on the lowest bid value. And we are also giving an option for the auctioneer to select the number of public votes that he has got. Public votes here, it's more or less a positive vote, right? So across a bidder, or here in this case a contractor who wants to say lay a road, etc. We want to say, okay, at least he's got say 2 positive votes. Just giving an example here. Or the year of establishment, say it should be less than 1975. So these are the options that as a filter condition can also be selected by the auctioneer to determine the who was the contract auction winner. And in case of a product auction model, this is not applicable. So they just take the highest bid value has come across so far in the auction process, and he is actually the bidder, that bidder is actually determined as a winner. So for a product auction, so the non-bid winners, right? So who did not win the auction, their money is actually returned. So whatever bid value that they have placed. So here you see we are adjusting the FI balance even before the bid is placed. So this is specifically to ensure that the bidder has got the payment capability if he or she wins the auction. So we are actually ensuring that the amount is returned back. So once the winner is determined and the bidders who did not win the auction, their amount is returned to the respective FI accounts. And at last, the auctioneer can reset the auction to enable this application to establish a newer auction unit. Implementation. We have actually developed our smart contracts in the Solidity version 0.5.9 and deployed them and validated using the Remix open source application. So on the screenshot here on the left side, you can see all the methods that we saw in the smart contract design, right? From the add FI to the bidder registration to the adding auction, looking at who is the get the contract bid winner, get the highest bid. So all these methods are now enabled in the deployed smart contract. Data setup for the product auction type. For the sample data setup, we are using the auction name as a phone, and the products or the contract auction type, this is actually going to be a product auction type. We are also establishing the FI accounts here. So the bidder name details are here, their respective account numbers, and the amount balance is provided. The ETH address is one of the validation criteria and a secure mechanism where we are giving saying, okay, a bidder one can register themselves or place bid only from the specific address. So bidder, there cannot be a bid that come from, let's say, a bidder to, or a registration can happen from this address. So we are ensuring from a security standpoint as well, like this account number. So when a bidder is trying to self-register themselves, it is ensured that the account number matches and the address from which a registration comes matches with the FI account details. So that's the way this is ensured. And at last, so the bid values, right? So for this iPhone phone auction product type, we are saying the bid, each of the bid values are like 500, 1500, 1000 and 1450. So these are the different bid values provided. Looking at the results. So once all the bids are placed, so when the admin clicks on get highest bid from the Remix window, so he will see that the bidder 2 has the highest bid of 1500. So this is how the winner is determined. And so now let's say the admin decided to end the auction by using the end auction functionality. The bid winner details are updated by the admin using the update auction winner amount method. So once this information is updated, the transparency is enabled via the get auction winner. The reason I'm saying is that even the non-admin can actually go and look at who won the auction that by giving the auction name, and by clicking on this get auction winner method, they can see here, okay, bidder to 1500. So this information is applicable and open to all. So that brings in the transparency concept here. And the final step, right? So even so once the auction is ended, so return bidder FI amount. So when we looked at it, so different bidders had bid different amounts. So once the admin, so this is enabled only for the admin. So once they give the auction name and invoke this method, so the FI account balances are adjusted again, where the original bid values of the non bid winners are returned back to their FI account balance. and bidder 2 here is currently 0 because his bid original account balance was 1500 and this winning bid value is also 1500, so it's a 0 value for the bidder 2, and the rest of them, if you see, the original account is restored, original balance is restored. And the final step in the process is the reset auction method, which will enable the network to run a new auction. Looking at the contract auction type, so we consider road construction as one of the contract auction models here, and the FI accounts and bidder can be reused. So here, if you look at it, we are using the year of establishment as well, like 2000, 2002, 2004, and 2006, and the account numbers match. Here, the amount balance is not used for the contract auction model because it is like the payment methodology is actually not derived from the bidders here, but more from the auction admin. So the key concept here is around the votes from the public. So there are ETH address given here, and it is not mandatory for the public ID to follow the C because multiple people can also vote from the single account. The key unique identifier is going to be the public ID and the bidder combination. So a single public ID cannot do multiple votes across a single bidder. So that is a constraint that is enabled here. So based on going through all these votes, right, so different public IDs are there, but a single public ID can vote across different bidders. So that is a possibility. And for this road construction project, we are seeing the bidder value. Each of the bidders has given, saying bidder 1 says 10,000, bidder 2 says 7,500, bidder 3 says 20,000, and bidder 4 says 8,000. And based on the upvote and downvote, let's see the results. So here, when the admin is trying to invoke the get contract bid winner method, and he is also giving a specific condition saying the year of establishment of the bidder should be 2005 and he should have minimum of 1 public vote. So that is a condition that is given by the admin. So when he is invoking this function, he sees that the lowest bid value is of 7,500 and bidder 2 is a winner. Yeah, as we noticed, bidder 2 was established in the year 2002, which is less than 2005, and he has got even more than 1 vote. So this is correct. So this determines saying, okay, we are determining the correct contract action winner as well. And at last, so once the update auction winner amount is updated by the admin at the end of the auction, the get auction winner is open for all bidders to look at, saying, okay, who won this specific auction as well. And this is the final step is to reset the auction, so it is enabled for other auctions. From a conclusion standpoint, in this study, we've actually met all our set objectives. So we have leveraged the Ethereum and the smart contracts associated with it to build the seal bid auction for both the product sale and the contract scenarios. The transparency is also enabled where we are having this get auction winner method. And we have also validated that the winning bid for both the product and the contract scenarios are valid and correct. And the bidder's payment capability is addressed via using a finance intermediary account. And I have tabulated the results as well. So whatever 5 pillars that we wanted to achieve, right from the seal bid or FPSP auction, product sale scenario, usage of finance intermediary account, the contract scenario, and the public vote option. All those are yes, right. For the future works, so we can extend this research in the following areas. From a contract auction standpoint, there can be a milestone tracking process, and the payment can be based on the milestone tracking as well. So that can be one of the future work associated with this study. And public ID validation. So right now we are just giving government ID 123, 124 like that. So there can be a proper driver's license or an Aadhaar number, and there can be a backend validation so that we are ensuring the right individual is actually voting for the bidder. From a product auction, so again, so we can work with an actual escrow based system payment integration model where the payments are directly from their accounts, so it will be much more efficient. Thank you for giving me this opportunity to present my research topic, and I have given the references at the end of the slide.